It's okay if you're wrong. What do you think? Anyone? No one wants to say anything about the domain of this function? Give it a try, please. Anyone wants to save us?
Is it negative infinity?
Careful. Domain. Domain is read on the x-axis. Domain is read on the x-axis. Range is read on the y-axis. So we want to read from the x-axis.
Is it between 0 and 1?
Thank you. 0 and infinity, right? 0 and infinity. So there is a problem with log. Log is applied only to positive numbers. We had two other functions with problems. 1 over x minus 1. X could not be 1. That's another problem. We also have the square root of 2x minus 3. And we know that 2x minus 3 has to be greater or equal to 0. This is the third one. It's a problem function. Why? It's not defined on all real numbers. Let's look at one more shape, and then we look at problems. We also, at the beginning of the class tonight, we graphed the other shape for the exponential function, which is this. Still a to x. What was the base for this one? Is it less than 1 or greater than 1? You can say it's a silly question. Yes, it's a silly question because we already talked about this. It cannot be both, right? So this must be the one with a is between 0 and 1. Awesome. Remember, I have to graph this line. If I want to graph the function and the inverse, I have to graph the y equals x first. I realize that this function crosses at this point, so will the other one. Okay, so let me show that. So when I see, when I fold the graph on this mirror image, if you want, I realize that this will have to be the graph of the inverse function. So then the graph of the inverse is this, and it has to cross at the same point. What will this be? Of course, log base a of x, where a has to have the same property. Still has to be between 0 and 1. So for this one, the domain is still the same, between 0 and infinity. So there is a problem. So no matter what the base is, this function is among the list of 3 with problems, potential problems. This cannot have denominator 0. This cannot have a quantity that is negative. And this cannot even be 0. This quantity, whatever it is, has to be a positive number. Okay, so now we are ready, with all this explanation, we are ready to choose domain. Questions. Find the domain of each logarithmic function. We're not going to graph at this point. We can only graph with the graphing calculator, so we can just punch it in. It's not important at this point. We're going to graph a lot in chapter 3, you'll see. Okay, so from 51 through 60, let's choose and find the domain. And I am on page 6, yes. So let's find domain. So let's choose. If you don't choose, I will. I'll start with 53. In 53, we have f of x equals natural log of 4 minus x. They're asking us to find the domain. I will assign a homework problem from here. So I'm gonna make sure that you understand there is no need to graph. I only want you to determine the domain. So, can anyone tell us what we have to write? And then find the domain. Don't give me the domain from the beginning. I want everyone to see what we need to find, or what we need to do first. So, what do we have to write? Anyone, please.
Sorry, really quick, what is the letter before the parentheses?
I'm sorry, natural log. Sorry.
Oh, okay, thank you.
Sorry about that. So what do we have to write? In order to find the domain, we have to write something. What do we need to write? Keep in mind, the log has to be applied to positive numbers. So what should I write? What has to be positive for log to exist?
X.
Log is not applied to x. Let's read this together. Natural log of 4 minus x. So what is natural log applied to? Anyone, please? What is natural log applied to? It's not applied to 4 and it's not applied to x, but it's applied to,
4 minus X.
that's it. Indeed, it is applied to 4 minus x. Move 4 to the other side. Divide both sides by -1. What do I get? What happens now when I divide both sides of an inequality by a negative number?
X is less than 4.
Very good. And this is the domain of this function. Exactly what we see here. -∞ to 4. Great job. Good. Do you feel like choosing anything else? Is there another problem we want to look at, or we move on to logarithmic equations?
Can we do?
Yes, of course.
68.
We're not in 68 yet. We will. We are still choosing. That's okay. I mean, if we don't need to choose another problem from 51 through 60, we'll go to 68.
No, I want to do one with the two sides. So 55 or 56.
Very good. 55. Let me copy it. In 55, we have y equals natural log of x plus 3 plus natural log of 5 minus x. Perfect. Very good pick. Move stuff out of the way. Okay, perfect. This function is a sum of two functions. Both have to exist for y to exist. So let's start slowly. What condition or restriction or something that has to happen? Okay, I'm sorry, this is ln. What has to happen for this function to exist? And I'm going to write it here. And then we'll move on to the second one. But for the first one to exist, what has to happen? You see, it's absolutely the same situation. So what do I have to write? For this log to exist, what do
X plus 3 must be greater than 0.
Excellent. Now let's move on to this one. For this log to exist, what do I have to write? And this is a kind of a system of inequalities. Not kind of, it's a system of inequalities. So what do I write for this one?
5 minus x greater than 0.
Good. I know how to solve this. I know how to solve this. Divide both sides, switch the symbol. So now I have to represent these two on a number line or real line. Greater than -3. So if 0 is somewhere here, this is -3. Greater than -3 is this. Less than 5. 5 is somewhere here. Less than 5 is this. The domain of y has to consist of x values that make these two exist at the same time. If one exists and the other one doesn't, y does not exist. If this exists and this doesn't, or vice versa, I think I already said that. If this exists and this doesn't, same problem. I cannot add 5 to undefined or undefined to 10. Both have to exist at the same time. Which territory, which x values will I have to pick so that both functions exist at the same time, because this is the function that is the sum of those. What do I have to write?
-3 and 5.
Of course, exactly where I see both colors. I see this purple, indigo, whatever it is, and the red. So that's it. That's where I see both. Here I only see red. Here I see only that purple, whatever it is. So this is what I need to choose. I need to choose -3 to 5. And that is the domain of this function. Excellent. Thank you. Well done. Okay, let's move on to, now we can pick equations. And then finally, I want to pick word problems. So let's look at an equation. So these are log equations. Let's choose 63. So we have 2 natural log x equals 9. I have to refresh your memory on how to solve log equations. So before we even attempt this, I have to refresh your memory on the following. Any log equation can be replaced by an exponential equation, comma, and vice versa. Any exponential equation can be changed into log equation. Any log into exponential, any exponential into log. They are inverses of each other. The functions are inverses of each other. So how does this work? Log base a of x is a number y. This is a log equation. Remember the double equivalency. This implies this, this implies this. And here's how we do it. Please pay attention, it's very easy. We start with the base counterclockwise, the base raised to y equals x. The base raised to y equals x. From here, here, here. This is what I mean by this sentence. Log equation changed into an exponential, and exponential back into a log. Why do I need this? I need it right here. First of all, can we simplify? Can we make it easier? Yes, and we will divide both sides by 2. So we have natural log x equals 9/2. Remember, the base is hidden, but we know it's there. Now, how do I write the equivalent exponential equation based on this? base raised to y equals x. How do I write this here? Applying this property. Base raised to y equals x. Can anyone give us the equivalent? Anyone? Anyone, please? Give it a try. I'll write it. Ready?
E 9/2
Excellent.
is X.
That's it. And that's how I find it, and I have to put in the graphing calculator. Brilliant. Thank you so much. Thank you, thank you, thank you. So here it is. So I have E. I have to use this. Parentheses, maybe not, but you know me. 4.5 or 9/2, it doesn't matter. And that's my X. And I click enter, and I get 90.02. So X equals 90.02. You can always check. Plug it in here. 2 times natural log of 90.02 has to equal 9. You should always do that, just to make sure. So 2 natural log. I didn't mean that. 2 natural log. I will just copy the answer. Copy the answer so I don't get an error. And when I click enter, if I don't get the answer to be 9, then I know I have an error. The answer has to be 9. Now, if I round it and I don't put the previous answer and I put 90.02 as I wrote it, an approximate, I will not get 9. I will get close. But if I use the previous answer, I will definitely have to get 9. Good. We can look at other equations, or we can look at a word problem. So I know I only have 4 minutes left. I wanted to get to a word problem, but it's okay. So let's choose another equation and then word problems on Thursday. We haven't done any calculus other than some limits tonight, but it's okay. It's a good refresher. We need this for the chapter. So let's choose another equation. I will choose 67. So we have natural log of x plus 3 plus natural log of x minus 3 equals natural log 7. Okay, perfect. So before we even address anything, let's address the domain. It's very important. So can anyone tell us what we need to write for this to exist?
X plus 3 greater than 0.
Thank you. And for this one?
X minus 3 greater than 0.
Brilliant. Thank you very much. So then we have x greater than -3 and x greater than 3. When you look at the real line, this is 0, this is -3. And then for the other one, where is the domain for this function? There is no domain for 7. It's always a number. So what is the domain? Where both exist at the same time.
3 to 5.
Awesome. 3 to infinity. Awesome. So what I'm saying here is this. If I do not get a number as a solution between 3 and infinity, I'll say no solutions. This is extremely important. You can say, I don't want to stay the domain. I promise to go back and check because this is a function with problems. That's fine too. But as a practice, I think it's better to practice the domain. But I accept that. If you promise to always go back and check, that's fine. Now, we have to condense this piece. Condense. What does that mean? Well, you remember one of the properties that we discussed, the one with plus. So this is dynamic from left to right and from right to left. If I have a sum of two logs in the same base, I can change it into this. If I have a difference of two logs with the same base, I can change it into this. So we're using this one. So in order to condense, I will write natural log of x plus 3 times x minus 3 equals natural log 7, because it's a plus. And finally, log of this number equals log of this number. This will only happen if this equals that. When I multiply, I have x squared minus 9 equals 7. This must be the case. Or x squared equals 16. Now we know how to solve this. Can anyone give us, it's quadratic, can anyone give us the two solutions of x squared equals 16? Since it's quadratic, I have to get two solutions. What are they?
4, -4.
However, thank you, brilliant. However, look carefully and say, ah, only what?
X equals 4.
This is not in the domain. And if you plug it here, -4 minus 3, you cannot take the natural log of -7. If you plug it in here, -4 plus 3, you cannot take natural log of -1. Yes, I will stop right this moment. I just want to show you. The calculator will scream very loudly. Very loudly. It will say, lady, you lost your mind. Okay? So you either state the domain or you check back in the original problem.